In this video, we will take a look at different signals of different frequencies which are in the audible range. We will listen to the signal and see its spectrum on the spectrum analyzer, which is a part of Audacity software. So you can go to this website, which is mediacollege.com. If you are trying it, please download the WAV files because Audacity needs some additional extensions to handle MP3 audio clips. So download these WAV files and we are good to go. So let's listen to these different frequency signals. Let's start with 100 Hz. Now let's see its spectrum on Audacity. We will open the 100 Hz 30-second waveform using Audacity. I'll just drag and drop. Now we will read the files directly from the original. Click OK. Now we can see the waveform. Let's zoom in. So we can see a continuous waveform. It is continuous. It is periodic. You can see that this portion of the waveform corresponds to one period and it is getting repeated throughout. So this is one period of the waveform. So this part is being repeated. Now what is the time period? You can see here that this is the time axis and here it is 0.010 corresponds to one period. So we know the relationship between period and frequency of a periodic waveform. Frequency is 1 by time period. So let's use a calculator. Now 1 divided by time period, that is 0.01. We will get 100. So we have a 100 Hz waveform on the timeline. Now we will go to analyze and click plot spectrum. Now I have taken the window size to be the maximum and the function I have used Blackman window. Now like we have expected, we can see a peak at 100 Hz. Let's close this. Let me add one more track to it. So I'll choose the 250 Hz 30-second audio clip. I'll drag and drop. I'll click OK. Now let us zoom in. On the top track we have the 100 Hz waveform and in the second track we have the 250 Hz waveform. Now let's maximize the 250 Hz track. So we can see that the time period corresponding to the 250 Hz waveform is 0.04. Now let's cross check. That is 1 divided by 0.004. That is 250 Hz. Now let's see them side by side. Just like we have expected, the 250 Hz signal have more cycles in a particular time interval. Now let's select the 250 Hz track alone and go to analyze and plot spectrum. So like we have expected, we can see a peak at 250 Hz. Let's close this. Now let's select both the tracks and plot the spectrum. So we can see one peak at 100 Hz and another at 250 Hz. Let's close this, and now what we will do right now is we will mix a 100 Hz waveform and a 250 Hz waveform, save it and reload into Audacity and see how it looks in time domain as well as frequency domain. So it is like adding two signals. There is 100 Hz waveform and another 250 Hz waveform. Let's do that. Let me manipulate it a little bit. I'll take the 100 Hz waveform. I'll go to effect. I will amplify and I will actually attenuate the waveform by a factor of 5. Click OK. I will do the same for the second track. We'll go to effect, amplify. I'll attenuate it by a factor of -5. Now let's play this audio. Now we will go to file and export audio. Now what it does is it mixes or adds the two signals, that is the 100 Hz and the 250 Hz waveforms, and mixes them into a single file. Now I'll import the file we have just saved. We'll go to import audio, select this waveform, click OK. Now we have three tracks side by side. Let's zoom in. Now we can see this is our 100 Hz waveform, this our 250 Hz waveform, and we have mixed them to form the third signal. Now this is what we get when we add these two signals, that is the 100 Hz waveform and 250 Hz waveform. Now let's select this resultant track. I have selected it. I will go to analyze. I will plot the spectrum. So we can see a 100 Hz, a peak at 100 Hz and 250 Hz. Now in this video we have seen different signals, different frequency signals in time domain as well as what it looks like in frequency domain. We have mixed two signals and seen it in time domain as well as frequency domain. In the next video we will discuss about the importance of discrete time signals.